Imagine a world where we could travel at the speed of light. A world where the most profound questions about our existence and the mysteries of the universe could finally be answered. For decades, scientists have been tirelessly working towards achieving this seemingly impossible feat. And now, thanks to NASA's groundbreaking research and discoveries, we might be closer than ever to unlocking the secrets of light-speed travel. But before we delve into the future, let's first understand what lightspeed actually is. As the name suggests, it is the speed at which light travels through a vacuum, approximately 671 million miles per hour. It's mind-bogglingly fast, and in fact, it's the fastest speed at which anything can travel in our universe. According to the laws of physics, only electromagnetic waves, such as light, radio waves, and gamma rays, can reach this incredible speed. They are known as massless particles, meaning they have no rest mass and can travel unhindered through space. But what about objects with mass, like us humans or spacecraft? Unfortunately, it's considered impossible for them to reach the speed of light. As an object approaches the speed of light, its mass increases exponentially, requiring an infinite amount of energy to accelerate it further. Even our fastest man-made spacecraft, like the Parker Solar Probe, can only reach speeds of up to 430,000 miles per hour, a mere fraction of light speed. In the past, NASA has focused on developing spacecraft that can travel at high speeds within our solar system. They've utilized gravity assistance from planets to increase the speed of spacecraft like the Parker Solar Probe and the New Horizons spacecraft. They've also explored various propulsion technologies, such as ion thrusters, solar sails, and antimatter propulsion systems. However, none of these advancements have come close to achieving light-speed travel, especially with the added challenge of carrying humans or any living organism on board. But NASA's thirst for knowledge and exploration knows no bounds. In recent years, they've been delving into new frontiers of research, pushing the limits of physics itself. One such endeavor is the Advanced Propulsion Physics Laboratory, also known as Eagle Works Laboratories, located within NASA's Johnson Space Center. Led by Dr. Harold Sonny White and his team, this research facility focuses on developing advanced propulsion technologies, including those that could potentially enable faster-than-light travel. The laboratory explores the possibility of warping the fabric of space-time itself, as proposed by Dr. White in 2012. By manipulating space-time, they hope to overcome the speed of light barrier. But it's not just warp drives they're investigating. The laboratory delves into the behavior of matter and energy in extreme environments, tests advanced propulsion systems, and explores theories like wormholes that could offer shortcuts through space-time. While their research may have seemed purely theoretical in the past, it has opened new doors and addressed questions that were previously unexplored. Their ultimate goal is to develop propulsion technologies that would allow human exploration of the solar system within the next 50 years. And though the energy requirements for faster-than-light travel were initially deemed astronomical, scientists have made significant progress in reducing those estimates. Now, let's shift our focus to another brilliant mind at NASA, David Burns. Building upon the foundation laid by Dr. White, Burns proposed a concept that could potentially propel a spacecraft at the speed of light. His idea revolves around the M drive, an electromagnetic propulsion system that generates thrust without the need for traditional propellants. The M drive concept was first introduced by Roger Scheuer in 2001, and it raised eyebrows due to its seemingly contradictory nature. It appeared to defy the law of conservation of momentum and other well-established physical principles. However, Burns saw potential in this unconventional technology and put forth a new concept for an engine that could harness the M drive to achieve light-speed travel. The research and development in this field are ongoing, with promising results emerging from initial tests. Burns and his team are exploring the feasibility of creating an engine that can harness the M drive's thrust to propel a spacecraft at unprecedented speeds. Their goal is to unlock the secrets of this groundbreaking propulsion system and pave the way for future discoveries that could revolutionize space travel as we know it. And been dubbed the impossible drive by the media, today we'll explore a different concept, the helical engine. Imagine a propulsion system that could potentially reach mind-boggling speeds of 297 million meters per second. That's what Burns, a brilliant scientist, envisioned when he developed his helical engine. Drawing inspiration from high-tech particle accelerators like the ones found in the Large Hadron Collider, Burns aimed to harness the incredible power of mass change at the speed of light. In a paper uploaded on NASA's website, Burns used a clever metaphor to explain his concept. He compared his helical engine to a weight inside a box, threaded on a line with springs at either end. By manipulating the mass and speed of the weight, he theorized that the engine could generate a significant thrust. Imagine the possibilities. With the helical engine, travel time between planets and even galaxies could be reduced to a fraction of what it is currently. Not only that, but the need for large amounts of fuel would be diminished, making space travel more efficient and sustainable. Scientists and engineers around the world are eagerly watching the development of the helical engine. It holds the promise of a new era in space exploration, one where we can reach unimaginable speeds and unlock the mysteries of the universe. But how does the helical engine work? Well, it utilizes particle accelerators similar to those found in the Large Hadron Collider. By using electromagnets, particles are accelerated to high speeds and then recycled back through the engine to be fired again. This process capitalizes on Newton's laws of motion, where every action is met with an equal and opposite reaction. To better understand the principle behind the helical engine, let's dive into a simple experiment. Imagine a spring placed inside a box. When the spring is compressed, the box moves in the opposite direction. As the spring reaches the end of the box, it bounces back, changing the recoil direction of the box and creating a loop. Now imagine if the weight inside the box were to increase in one direction. This would result in a larger push in that direction, generating a greater thrust. This is where special relativity theory comes into play. As a particle approaches the speed of light, its mass increases. By manipulating this mass change and utilizing ions, it becomes theoretically possible to generate thrust in the helical engine. However, the practicality of the helical engine presents its own challenges. The engine would have to be large, measuring 200 meters long and 12 meters in diameter. It would require a staggering 165 megawatts of power to generate just 1 Newton of thrust. Furthermore, meaningful speeds could only be achieved in the frictionless environment of space. But let's not forget the EM drive, the propulsion system that has caused quite a stir in the scientific community. Some researchers claim that the EM drive violates the laws of physics as we currently understand them. Martin Tajma, a researcher at the Dresden University of Technology, suggests that the EM drive, like other inertial propulsion systems, may not work in a friction-free environment. There's more to consider when it comes to traveling at the speed of light. Time dilation, as explained by the theory of special relativity, becomes a factor. As an object approaches the speed of light, time slows down for the observer on the moving object. This could lead to aging at a slower rate than the rest of the universe, creating unique challenges for the crew. Additionally, detecting obstacles in space would become nearly impossible at the speed of light. Collisions with planets, stars, and other celestial bodies could have catastrophic consequences. The immense energy required to reach such speeds would also damage the surrounding space-time fabric, creating disturbances throughout the universe. And let's not forget the human cost. The immense forces involved in traveling at such speeds could cause severe injury or even death. It's a risk that must be carefully considered. But despite these challenges, the prospect of achieving light-speed travel holds immense potential for scientific exploration and discovery. Imagine astronauts equipped with the ability to traverse the cosmos at unimaginable speeds. We could study distant galaxies, delve into the mysteries of black holes, and gain a deeper understanding of dark matter and dark energy. And perhaps, just perhaps, traveling at the speed of light could unlock the secrets of time itself. Exploring the origins of the universe and studying the Big Bang and the first moments of existence could provide us with answers that have eluded us for centuries. So, while the science behind the helical engine and the EM drive is still uncertain, it's crucial to remain open to new and potentially groundbreaking ideas. Aerospace technology is constantly advancing, and what seems impossible today may become reality in the future. Remember, there was a time when we believed that airplanes were impossible. Yet here we are, soaring through the skies. So, Who's to say that an aircraft capable of traveling at the speed of light won't be built soon? The only question that remains is, when? With that said, thanks for watching, and until next time.